Good morning and welcome back. I hope you're getting some time to relax in between educational opportunities here. Uh, so today we're talking about normal distribution again, and we're going to continue to use this to answer some questions. So yesterday we talked about the empirical rule, and I don't believe I gave it that name, but the empirical rule tells us um, an approximate shortcut here where 68% of our data lies between one standard deviation, 95% of our data lies within two standard deviations of the mean, and then finally 99.7% of our data lies within three standard deviations of the mean. Um, so if we're looking at questions where we know the mean and we know the standard deviation, we can use the empirical rule to approximate outcomes here. So we're going to do a couple questions together, and then I'm going to have you do a couple practice questions on your own. So battery lifetime. So in example A, we're talking about batteries and how long batteries last. So the mean lifetime is 500 days, and the standard deviation is 61 days. The question we're trying to answer, to the nearest percent, what percent of batteries have lifetimes longer than 622 days? So first thing we should do is we should draw our normal curve in order to kind of break this down and analyze it. Um, so we're going to do our best here, right? It should be symmetric. It should be relatively bell curved. It takes a little bit of practice, myself included there. So my mean is, I could do a little bit better than that. Let's put that better in the middle there. So my mean, I'm going to use mu here, is 500 days. And then each one of my standard deviations, we're adding or subtracting 61 days. So 500 plus 61 is 561. So that's plus one standard deviation, minus one standard deviation would be 439. And then we'll just keep doing that. We'll add two standard deviations. Oops, too much. Add three standard deviations. So that would be, let's see, 622, and then 683. So I have my 622. I could probably stop there, but I like the symmetry, so I'm just gonna complete my picture there. So going back 61, that's 378, and then 317. Okay, so we've got our picture here. Now, when it says it has lifetimes longer than 622 days, then that means that we're talking about this section here and going to the right of that 622. So I need to know what that blue highlighted area is. Now, I know from my empirical rule that everything between two standard deviations, so within two standard deviations, what I'm highlighting in green is going to be 95% of the data, which means that everything on the outside, which I'm going to highlight in pink here, everything on the outside there is going to combine to make 5%. Now, since it's split evenly in half, half of 5% means that we've got 2.5% on either side here, right? That would add up 2.5 plus 2.5 plus 95 would equal that 100% that we're looking for. So that means that our total missing area here, our percentage, is approximately 2.5% of batteries. Now, even though the empirical rule seems pretty finite, it's still an approximation of an outcome here. Right, these are based on samples. We're not testing every single battery that ever was made. So approximately 2.5% of batteries. So let's do another question here. And again, just to see how we're going to use the normal distribution to make approximations and make inferences about data. So Professor Ragsdale has 184 students in her college mathematics lecture class. That's quite a big college lecture class, but some classes are pretty big. Anyway, so the scores on the midterm exam are normally distributed with a mean of 72.3 and a standard deviation of 8.9. The question we're trying to answer is approximately how many students in the class can be expected to receive a score between 82 and 90. and we're going to express our answer to the nearest student. And this is interesting because before, like in the first example, we were looking at percentage, right? But now we're going from a percentage to a number of students. Whoops. So we will, because the normal distribution tells us about percentages, we're going to have to start there and then convert that to a number of students. So again, I'm going to draw my bell curve. I'm going to make it nice and symmetric, mostly symmetric, and put my mean in the middle, so 72.3. And then again, I want to be adding my standard deviations or subtracting my standard deviations. Plus 2 standard deviations, plus 3 standard deviations. Again, I'm using that lowercase sigma for my standard deviation. We're going to probably do that pretty consistently here. So standard deviation of 8.9, I'm either going to add or subtract 8.9, so that'll be 81.2, 90.1, and 99, and then subtracting 8.9 will get me 63.4, 54.5, and 45.6. Okay, so between 82 and 90, now we've got 81.2 and we've got 90.1. So we are approximating. It does say approximately how many students. So we're looking for what is the percentage of this little slice right here. So that's kind of our area of question. And again, we can use the empirical rule. So according to the empirical rule, everything within one standard deviation is going to be 68%. And then everything within 2 standard deviations is going to be 95%. And so if we think about kind of that overlap there, or I should say the difference between the two, if we think about these outside areas, so the one that we're looking for and its twin on the other side, that would be the difference. That would be the difference between 95% and 68% would leave us with 27% in between the first and second standard deviations. But again, we're only looking at half of that, and 1/2 of 27% is equal to 13.5%. So within this little area is 13.5%. However, again, we're looking for numbers of students, not percentages. So I'm going to take that information and I'm going to think about, I need 13.5% of our question was 184 students. So if you remember how to find the percentage of a value, you do multiplication there. So that will be 184 times, not 13.5. That'll give us a much bigger number. We want 0.135. And so when we do that, we get 24.84. Now it does say express our answer to the nearest student. I don't know about you, but I don't know what 84 hundredths of a student looks like, besides kind of a mess. And since our values were a little bit outside of the range between 82 and 90, they weren't exactly spot on. I think rounding down to 24 students is a reasonable approximation because our boundaries were a little bit larger than our anticipated boundaries, and rounding up maybe isn't accurate here. So approximately 24 students. So you've got 2 questions, or I guess I should say 2 scenarios here, and I've got the normal distribution or the normal curve drawn for you. All you really need to do is label it with your mean and your standard deviation, and then a second example. So I'm going to have you answer a couple of questions here in the Edpuzzle, but do your work on these in OneNote, and we can check our answers together. So have a wonderful rest of your day. Take care of yourself. Go drink a glass of water before you do the rest of these questions. And hopefully we will talk in Zoom soon. All right. Stay well. See you later.